In the first part of the experiment, what we're going to do is measure the current going through a circuit that has 7 different resistors in it. So we're going to do one at a time. We'll go through 7 different resistors, all with the same battery voltage. So we're varying the resistance in the circuit and going to see how the current changes as we do that. Now the circuit is going to be powered by a battery. This is a 6-volt battery, and we'll measure the actual battery voltage in a second. But this has a, if you can see on the screen, a positive and a negative terminal. So we've got the positive and the negative terminals here. And we're going to measure everything with this device called a multimeter. And the multimeter has different settings, and so I'll show you those as we get to them. But it can measure current, voltage, and resistance, all 3 things that we're interested in here to verify Ohm's law. Now the multimeter has leads coming off of it, positive and negative sides of the leads here. So we have a red and a black that we can attach to things, and we can either connect the meter in series or in parallel depending on what we're going to measure. Let's try the battery first. So I know this battery is 6 volts, or it's supposed to be 6 volts, so I put it on this setting here which says 20V. That means it can measure voltages up to 20 volts. And I can connect the battery this way, so I can connect it on here, and we see that the actual battery voltage is 6.19 volts. So that's something you'll want to record. The battery voltage that we're using is 6.19 volts, and it'll be the same battery for all of the 7 resistors that we use. All right, so let me disconnect this here. And now that we know the battery voltage, we're going to want to know the resistance that we're using. And so I have here a resistor. This is what a resistor looks like. It has no function other than to provide resistance in the circuit, and they're color-coded. So if you use resistors a lot, you would be able to read the pattern of colors here to tell you exactly what it is. This is a 100 ohm resistor. I have canisters over here, and they're labeled. This is a 100 ohm resistor. But again, we don't want to just take their word for it. We'll measure the resistance. And on the meter, there's settings for resistance here. And for a 100 ohm resistor, we can use the up to 200 ohm setting. So I'll clip either end of the resistor to measure its resistance. Let it settle for a second. Okay, so let's say 101.8. It keeps fluctuating up and down. 101.8. Okay, so that's our resistance for this resistor. Now what we want to do is hook up a circuit and measure current. The current flow, as you'll see from the spreadsheet, it predicts the theoretical current. The theoretical current flow for this circuit with 6.19 volts here, 101.8 ohms here, is 60.81 milliamps. So according to Ohm's law, that's what we should get, 60.81 milliamps. The milliamp setting is right here, so that's 200 milliamps. And so we want the current to flow through the meter and then through the resistor and then back to the battery. And you can connect these in any order you'd like, but you just have to start someplace and then follow it in a line. So I've connected here to the negative terminal of the battery. Current electrons will flow from here through the wire, in through the black wire, then through the meter, and then back out the red wire over to here. And then I want the current to go through the resistor before going back to the circuit here and to complete the circuit over here. So if I just touched this, I should get a reading, okay? But I want to make it stay there for a second, so I'll use a clip. So now I've clipped onto the resistor, and I'll clip onto here, and then I can read the current in this circuit. I predicted it was 60.81, and what we actually get in the experiment is 58.6 milliamps. Now what I'll do is the same thing over and over again. So each time I'm going to disconnect this, turn off the meter so that I don't accidentally put more current through it than I want to, and by doing so damage the fuse inside. So I'm turning this off, and then I'm going to switch out for a different resistor. And so that was the 100 ohm. Now I'm going to take the next one, which should be 150 ohms. Sometimes these don't get put away right, so I want to make sure, for two reasons, that I have the right kind of resistor, and also that it is what it says on the label. So now I've disconnected from the battery, going back to just connecting to the meter here, and then I will turn it on to measure resistance. Now there's different settings here. This is 150 ohms, so I should be okay to put it on the 200 ohm reading. And I get 150, let's see, 151. We'll call it 151. And at this current, I shouldn't say current, at the present value of the voltage, what we predict is a current of 40.99, so about 41. So now I'm going to connect back to the battery. But before I complete this circuit, I need to put it back to the milliamp setting. And then we'll see what we get here for current. And it's 39.9. Okay, turn this back off. And I'm going to repeat this procedure for the rest of the resistors. And so you can collect the information from the video. I won't necessarily talk over this the whole time. Now this one is supposed to be a 560 ohm resistor. And so I put it on the next setting up, which goes up to 2 kilo ohms. So the reading here is in kilo ohms. So it's 0.549 kilo ohms, which would be 549 ohms. Okay, go back to the milliamp setting. Connect to the battery, connect to the resistor, 11.1. So this one, we're still on the 2 kilo ohm setting, so it's 1.478 kilo ohms, or 1,478 ohms. To the milliamps setting, and now we have 4.1 milliamps. So as you can see, we're increasing the resistance, and as we're increasing the resistance, the current is going down. Just a few few more to do. Higher. Okay, so we had to go up to the 20 kilo ohm setting because this resistor here is over 3,000. So it's 3.25 thousand ohms. So 3,250 is what we're going to call this one. 3,250. Back to milliamps. And we have 1.9, which is exactly the prediction. Two more. Okay, we're going to measure the resistance of this next one. And we're still on the 20 kilo ohm setting here because it's such a big resistor, and we get 4,620. And now the current is 1.3. One more to go. $5,530. Okay, and now for the last current reading, we will see 1.1 milliamps. And that's it. Those are our 7 data points. So you have a voltage of 6.19 volts and a range of resistors from about 100 ohms up to over 5,500 ohms. And we have current readings in milliamps for all 7. And so now we can see the relationship between resistance and current and verify Ohm's law.